Paul Preiss, your host du jour. I'm talking to Zach Gardner today, the chair of our AI architectures community, a member of our chief architect board of directors, and all-around AI guru. So, hey, Zach,
Thanks
how
for
are
having
you?
me on the pod. I'm doing well. AI guru, that's a new one. I always, whenever I see, anything guru, I always get a little bit skeptical. So,
Fair enough. How do
I
you
tend
feel
to
about
think myself
Sherpa?
as, ooh, I like the thesaurus on that one.
Yeah, the Sherpa is a
Yeah,
is hard to
yeah, just a guide.
to argue with. Yeah, it's
Yeah,
just a
and yeah,
guide.
I'm just here to have a fun time.
So, um, so I guess the first thing I'm interested in, what's going like what's your take on where we're at architecturally with AI, um, and just in general and industry wide, where do you think we sit right now?
Really the story back in 2023 and kind of early 24 was it's all about LLMs. Like LLMs was all everyone could ever talk about. And, I started to get a little bit skeptical about that, honestly. There was just so many that were coming out. I mean, even Google, like it's like every day someone releases a new LLM, they put it on like the LLM arena and they're all like battling against each other. But I was always struggling to figure out like where exactly that would actually take us in enterprise architecture. Like are LLMs, truly unique, or are they just a commodity, so to speak, that you could, swap out, like microphones, you can swap out one microphone for another. Sure, there might be a little bit of a difference in it, but it's a microphone. Like it does like a task. And one of the things that I've been seeing kind of get more and more traction as I've been talking with banks and hospitals and pretty much every other sector are really AI agents. I think one of the ways to think about an AI agent is instead of it being it's like robotic process automation on steroids, but you're not interacting with it through like a traditional coding interface. Like your API is actually natural language, and you can describe what you want, and you can have these agents go out and do the things that you wanted them to do. I think that is
So,
probably, yeah, go ahead.
no, I want to interrupt here because I'm all about the science and I'm all about the fundamentals of an approach, right? I was saying that we would be repatriating cloud while everybody was still trying to move to cloud work, everything to the cloud, and called me an idiot. I was saying microservices were not the best design pattern for all problems,
Mhm.
and people were busy calling me an idiot. Well, they don't call me an idiot as much anymore because uh, what is an agent versus an LLM? We had a chief architect forum in-person session in the Netherlands just last week with about 10 chief architects from, Fortune 500 size companies. And the question about agents came up, and we started to define, we started to say, well, who's got the definition of what makes something an agent or not? And there was a general sort of in the room, like, well, where is so before we say agents are going to do anything different than LLMs, what makes something an
Mhm.
agent?
Easier to understand it by contrast. An LLM, you ask it questions, it gives you answers. An agent, you ask it a question, it does a thing. So if you wanted it to say, hey, I want to know from my payroll, like what was my payroll last month? How does that compare to this month? That'd be a question for like an LLM that you would have something where it would understand, what your payroll was through a RAG, retrieval augmented generation. The difference though is for an agent, you're like, well, this seems a little weird. Can you correlate maybe information from accounts receivable, information from accounts payable, and if there's a discrepancy, issue an invoice. That's not a conversation. That's actually a command. So if you want to think about it in terms of the gang of four, like it's the command pattern where you have this thing that's sitting out there and you can tell it to go do things. That's how I would differentiate the two.
So, okay, so it's an LLM that can call APIs.
Yes.
Okay. Because this is the fundamental question I have is so we identified four areas that would differentiate agentic, an architecturally relevant difference, because an LLM that can book a flight versus finding a flight is questionably not that different. And one is context. So one is how does it understand context? Now, obviously, you get that from the RAG pattern. The two is memory, right? It remembers the actions taken, and remembers whether they worked out or they didn't. Three is goal setting, meaning that there are some boundaries, both in negative consequences as well as positive consequences, or good things and bad things. The fourth was action, but complex action and controlled action. And the fifth was trust, meaning you had some way of describing how much you trusted the actions of an agent. Now, I don't know that that's a comprehensive structure, but it was one that helped to differentiate it from me. Now, what do we do then how do you teach somebody the uses of this architecturally? So because I'm terrified of a world where an empty-souled, probabilistic, non-deterministic system is allowed to act on our behalf. Mm-hmm. Like, that doesn't make me excited. That makes me scared. I want to turn off every port and take all of my data and credit back from everybody. So what for you makes this into something, and I'm a negative old coot, but what for you makes this exciting as a powerful architectural paradigm?
And I think you're right. The fifth element, if I remember your list right, was actually trust. And we as humans, I think, we just have to embrace the fact that we are inherently skeptical of a lot of these technologies, where it takes away, like, we call it agentic AI, but it's not that we are agents in this. Like, our agency has actually been somewhat diminished because we have relegated and decided that these tools are going to be the ones that act on our behalf. So starting with trust, I think, helps. And one of the things that I've seen that has really come along, kind of getting back to your original question, since probably the last time we talked about AI, is really the chain of thought reasoning. DeepSeek was the one that really popularized it. And, we all saw what happened with, the NASDAQ when it did. But the chain of thought is, instead of just giving you an answer, it's showing you the work. Like my, fourth grader always tells me, her teacher asked her, it's not just enough to have an answer, you have to show the work. So what these LLMs are doing, being able to show kind of how they're reasoning about things, that I think helps people get a better understanding of the trust of, this is something that is actually thinking through these things in a logical way. But it's the difference between another, kind of technical analogy, a difference between a Terraform plan and a Terraform apply. You always want to see the plan before you do the apply. If you just kind of blindly go into it and you don't look that, oh, this is actually going to destroy my database and recreate it, those are probably okay for a bit more fungible resources like containers, which are stateless. For databases that are stateful, you kind of want to see what's going on behind the scenes. So
come on, just pull the plug and see what happens.
It was actually, I think, yesterday, it might have been 2 days ago when I was reading about it, Google came out with a people-centered AI user experience group where they're actually making recommendations on how people even need to be able to interact with these kind of tools. And the first thing you have to establish is trust. You have to understand that, these are tools, they're here to help you, and they have to explain what they're doing before they do a single thing.
I know this is going to be philosophical, and I apologize because I pride myself on only being philosophical in person, or as much as possible. Okay, you know me well enough to know that's a lie. But do we even have a model of trust for a non-deterministic system with its own ability to execute what could be sufficient, even something as small as deleting a database, right? That's actually a relatively small thing in the grand scheme of things. When you think about CrowdStrike, they didn't even delete any databases, right? All they did was just muck up the boot sequence. Mm-hmm. So, yeah. How do I even think about trusting a device? Do we have an authentication method that allows us to transfer a degree of trust and then link that back to a party. I mean, I know we got corporate liability, but that's a relatively flimsy shield when you're talking about people's safety, finances, identity. Hey, I decided the fastest way to get you to Antarctica would be to ship you in a box.
Mm-hmm. I think liability is one of those things that we didn't really appreciate when agentic AI first came out. I don't know if you remember the AI code assistant Devin. That was supposed to be the thing that replaces all developers. And it was funny too, because it would go onto GitHub on just random repos. It would go through the list of bugs. It would find a bug. It would actually, as it's trying to fix it, introduce another bug, fix the first one, and then later on come back and fix itself, which, depending upon the developers that you work with, I actually know a few developers that do, kind of something similar to that for job security purposes.
Windsurf has about the same level of bug introduction if you give it too broad a parameter.
Yeah. So it's a lot, the trust factor, the chain of thought, like I think all that definitely helps. But you also have to remember, like when, I don't know, a good example, when the cloud first came out, you're talking about, repatriating the cloud. We had already been on-prem data centers for, God knows how long. And so that paradigm shift, like just being able to accept the fact that things are going to change, that took a lot of CIOs and CTOs a while to be able to just accept the fact that they're going to have to do this and they're going to have to adjust, to where now you have some businesses that have never had an on-prem data center. That to them is sort of like, what America was like to Christopher Columbus, this like far off, distant land that we know nothing about. But once you get there, once you're a little more acclimated to it, it's the hedonistic treadmill. You eventually just kind of get used to it. So time and trust, I would say, are the two big things. How much agency you want to delegate to it, that's the liability part of it, because you never want to run into a situation where you have a lawsuit come in front of a judge and you say, well, it's not my fault because I might be a developer, but the AI generated it for me. You still always have to have a person there who is the liable party that says yes or no. That's a long-winded answer to your philosophical question.
Very, very good one. So tell me, how do I teach someone to think architecturally about AI and to use it effectively and ethically, right? Talk to me about the steps of educating. What are the things that we need to learn? What are the things that you're teaching in your AI architectures course? How do you make somebody into an architect that knows how to utilize the benefits of AI while being aware of and mitigating the risks?
You always start step one. What is the problem that you're trying to solve? What is the business use case? What is the business need? What is it that you're actually trying to accomplish? Pretend you don't even know what artificial intelligence is. You start with like, what is it that I am actually trying to do? So often what we get wrong is we'll say, oh, I have this new tool, blockchain, perfect example. I'm going to have a tool and I'm going to search out a problem for it to solve. When you do that, you always get things backwards. We are only here because there's some acute business need where they require a technical solution. So you start out, you understand the business problem almost to a fault. You have to almost be like so painfully slow with it that people are like, come on, let's get to the tech. I hear this AI thing, I want to use it. And it's like, well, let's understand what we're trying to do. The next is you have to evaluate what is the best solution for that. There are honestly some use cases, like I talk about this in the course, where AI is not appropriate. The ROI just simply is not there. If you are a company that has, I don't know, you ship salt across the United States or Europe, since you're in Europe right now, I got to include you, and you have 3 customers that you ship salt to, you don't need a machine learned trained model that will predict for you when someone is going to need their next shipment of salt. You pick up the phone and you ask them, when are you going to need your next salt? Like, if you try to implement an AI system to do that, the cost to get there, the cost to develop, the cost to deploy, you're not going to actualize that. So by starting with the business problem, you understand what it is you're trying to solve, you understand how much benefit is going to be there. Then you move on to, okay, what are some of the solutions? What are the things that I need to use? And it's only once you've gotten sort of past that event horizon that you're like, okay, I've talked myself into it. I know that I need to use AI. What are you going to use? Are you going to go with, more classical approaches, maybe just a linear regression or a classification or a random forest? I kind of go through all those in my course, but it's like there's a lot of tools that are already out there. What are the ones that maybe your company has licensed for? What are some of the considerations that you need to do to actually make sure that you can develop this appropriately? Because if you don't have developers that even know how to work in some of these languages, AI can actually help you with that, because you can then use code generation tools to try to understand, like, what is it that I need to do to actually implement these solutions? But you're always going through it in a step-by-step process. That's really the crux of it. If you want to think like an architect when it comes to AI, sometimes you need to know the situations where AI is not appropriate and how you evaluate that and move through the pipeline.
Let's get into the practical then. You said you were working on different kinds of algorithmic approaches. Are you looking at, because I know that LLMs get the shiny actress, brand new face in Hollywood. But there's a pretty big cast of players that we use pretty stably today, in machine learning and in other areas. What are the effectively the areas of that I need to know to be effective as an architect across multiple solution spaces, to know my options, to be able to weigh them against each other, and then be able to look at how their potential choices and their impact on a particular business case?
Mm-hmm. I like to go with kind of the Brooklyn Bridge example. If all my friends are jumping off the Brooklyn Bridge, depending upon which friend it is, I might have a different response than if it was other ones. So I always like to go out and could you do a survey of, like, what are the different things that people are actually using to solve this? When you're talking about classical AI and machine learning tooling, you're probably going to go with TensorFlow. I mean, there are a couple other tools out there that you could use. Microsoft has their own sort of AI studio, like a lot of them do, but honestly, for what they're worth, like it's really hard to be able to package those and to be able to move them from environment to environment. So I like to do a little bit of exploration first, kind of see what other people are using, kind of try it out myself. And if I'm going the classical route, I'm almost going to be going exclusively with TensorFlow. Like there's no other tool out there that is as comprehensive. When you're talking about agentic, there's a couple different branches you go down. When it comes to LLMs, by and large, I treat them kind of like commodities. There's so many new ones that come out every single week. They're all in, like what I said, the LLM arena. They're all battling against each other. There's no one silver bullet. There's no one sort of shining star when it comes to LLMs. It's just too new. There's just too many things that are coming out. So the way to architect for that is embrace that, is to accept the fact that, hey, I know that 7 days from now, it could be 7 hours from now, there's a new one that's going to come out that's going to be better. So I should never put all my eggs into one basket. What I instead should do is treat them as an API. I can call them. I should be able to swap them out when and if I need to. You always want to have them running in your own managed instance if you can. When you think about, data privacy and data exfiltration, it's always safer to have these.
But that's out of the reach. Isn't that out of the reach of most organizations? Like, unless I'm a Fortune 100, how am I going to manage my own real, I get small language models and small and my own trained data sets. That's a perfectly acceptable hardware to trade off. But effectively, I'm worried about two things, right? One is 5 years from now, we're going to have 50,000, 150,000, a million and a half deployed old LLMs, running in an instance off in the middle of an airfield, right? So think about it this way. I once was working with an organization that traced a set of IP pings inside. They were working on modernizing their landing, their air traffic control systems. They traced a set of IP pings to somewhere on the property, and only through a random act of maintenance did they find an old little data center sitting under the tarmac. It was one of these pull-up doors that had kind of grown over. And in there were like 75 Windows 3.1 machines running software that was a part of critical paths in their landing systems, right? That's obviously not a fabulous case study, but also not that rare in our business. Now, those were discrete systems that had a very straightforward output, yes? Which is why nobody, that's why they got lost. They did what they were supposed to do, and who knows, they changed staff and it was gone. But what do we do with a whole host of old, non-discrete system, probabilistic systems that just decide, well, I got old, right? I've now been consuming my own data for 30 years, and so now I'm a strange, morphed creature of knowledge. Like, what happens? How do you teach people to, our field loves shiny things and it hates old things. And instead of fixing them, we just ignore them and go like, yeah, I don't like that anymore.
No, to your
what's the big risks?
No, to your first question, when you have all these things sitting out there, I don't know if I would ever make AI part of the critical path. So let me back that up. LLMs specifically, I don't know if I would ever make them part of the critical path. Humans are part of the critical path. These are tools that are there to enhance and supplement us, but certainly not replace us. I think that was honestly one of the things that we got wrong about low code and no code tools, is that we tried to make these large scale applications out of them. And they work on the periphery. They don't really work when you try to build something massive out of it, and then you try to do a refactor, and it typically crumbles under its own weight. So by treating them as a commodity, by treating them as something that, can and will be replaced, they're honestly not that expensive. Well, I guess an understanding by comparison, databases, every company that I know that I work with that has, any sort of material value in their data, they don't say, well, this SQL Server instance is sure getting expensive. I'm just going to put my data on a shared database with everyone else. It's kind of like a hostile, sort of mentality. It's like, no, like this is a business cost. And I do think eventually it will become less prohibitively expensive, depending upon your run rate. You're running maybe at 1 or 2 or 3,000 a month. If you're, really hammering these LLMs on a managed instance, it still does take some wherewithal, some, technical know-how to get them set up. But it's no different than any other component of a business that has material value. And if you don't go down that route, if you try to use some of these, tools that are cloud hosted, you'll find out pretty quickly when you misuse them, because your data that you put into it, thinking that it was sensitive, be it, accounts receivable or, an inventory system, and you have, the open AI, chat GPT web hosted version, you give it that data and you ask it to reason about it. If you don't realize that that could be used potentially for training purposes for future models, and your data then becomes so enmeshed in the LLM that you can't, extricate it, like that's much more expensive than running your own.
You mean like all artist songs up to date? Zach, this has been an awesome, uplifting and deeply authentic interview. Zach will be teaching the AI Architectures course from Iasa on May 13th. Well, he is. This is the The first time out of the gate, definitely not the last. So definitely sign up for that on Iasa Global / AI architecture. And we'll be doing quite a bit more of these. For those of you who are not members of aiarchitectures.org, Zach and Stephen Kaufman are building the space for architects to come to learn about AI, to share what they're doing well. No bullshit, no hype, just real architects talking about real outcomes and how they got there. Anything you want to say at the end there about what you're doing there?
Oh, that's a good summary, and if you known me for long enough, you'll know that I'm neither an optimist nor a pessimist. I'm just a pragmatist. So I think that there are definite use cases for AI. There are parts of it that we should absolutely not use, and it should only be used in the context of how do we make our lives better. It is not a goal in and of itself. It's only a tool.
Drop the mic on that. Thank you so much.
Later.